Okay, so good morning to everyone. You are welcome to today's lesson, and today's lesson will all be about probability. Okay, so you have to know by the end of the lesson, these are the objectives that we are supposed to attain. Okay, so the objectives are there as and when we move on, and you realize that each objective well catered of, then you check. Okay, so when this is done, you check. Okay, after going through, if you know or you understand the two rules or axioms of probability, you check. So as and when, okay, we move on. Okay, so these are the objectives as you can read. So quickly, for probability, you basically need to know the definition or what is meant by probability and basic terms. Okay, so all that we are going to do today would be on the first objective. Okay, the first objective, understanding probability and the various concepts or terms related to probability. Okay, so probability basically, okay, is a mathematical term that, okay, we use to measure the likelihood of an event, okay, to happen or to occur. Okay, the likelihood, the chance of an event to occur. So probability, therefore, is all about what? Chance. Okay, so we predict, and we are going to predict anything that's prediction is involved. Then we are talking about what? Probability. Any chance, anything, or any chance process, okay, probability will be what? Involved. So please take notes. And like I was saying, this particular topic is not new to you. It's something that we did in JHS. And in JHS, you were told that this is the probability formula. Probability of any event, the E here is event, will always be equal to the number of outcomes in the event, okay, which we call the number of events, over the number of outcomes in the sample space, okay, which we call, okay, the number of what? S. So here, the number of E, where E is the outcomes in the event, because we said E is the event. Okay, and you know you've done set. So the number of S is what? The sample space. So here you are told that E is an event in an experiment with a sample space of S. So all the letters here are well defined. In math, okay, any letter used must be defined. So that's why when you introduce letters, you have to define your letter. Okay, because your letter, if not defined, could mean or have another meaning. So once you define it, then it means you've restricted what's that meaning. You've made it more specific. Okay, and you should also note that probability of any event can be a fraction, a decimal, or percentage. Only that usually when we talk of probability, okay, we leave our answers in what? In fraction. Okay, but you can leave your answer as a decimal or in what? Percentages as well. So please take note. Your probability results will not always be a fraction. It can be measured in terms of percentages or in terms of decimals. Okay, that will be it. Now, let's go and look at the various terminologies, okay, that we use, okay, or I will be using often in probability, so that anytime I mention it or I use it, you appreciate, okay, where we are coming from. However, before we come to the terms, any questions? Yes, please.
Please, can I take a screenshot of that?
Okay, you know, Irene, you are the one, right? Okay, so you hold on. I will send it to you so that because we are far behind time. Okay. Okay, thanks for your understanding. Okay, all right. Okay, so now this is what we, and I was asking any question before we come to the terms that usually we encounter in probability. If you are familiar with this term, I mean these terms, okay, we should be good to go. The lesson will be very interesting because I'll be making use of these terms very often. Any questions? Any questions? Does that mean we are all fine? I can move on. Okay, great. Okay, so now, can you hear me?
Yes,
Hello?
sir.
Great, all right. Okay, so the first, okay, term that we'll look at will be experiment or a trial. So anytime I mention an experiment, a trial, you should know exactly what I'm talking about. And an experiment or a trial is when the results are always uncertain. Okay, the results, okay, are always uncertain in series of action. So any action that your results will be uncertain, that action will be deemed as what? An experiment or a trial. Okay, so for example, if you flip a coin, okay, you are not certain of the result, whether you are going to get what? A head or a tail. So that process, okay, or that activity is what we call, okay, an experiment or a trial. So the activity of flipping a coin, rolling a die, okay, selecting a card from a deck, okay, that activity is what we call a trial. Okay, is that clear? Is the explanation okay? Hello, my professors, are you there?
Yes, please.
Is the explanation okay?
Yes.
All right. Okay. So then let's look at the second one, random experiment. So you can see that this time around, the experiment has been qualified. Okay. So we are dealing with what? A random experiment. And a random experiment, okay, is any experiment, okay, whose results can never be predicted. Okay. So anytime you have an experiment and you can predict the results, then it ceases to be a random experiment. So please take notes. Okay, so anytime we mention random in probability, okay, then it means we are looking at your experiment being a fair experiment. Okay, so it's like if I go to maybe a class in Wesley Girls Holy Child, okay, and I am going to look for a girl in Holy Child in a class. Obviously, I know that I'm going to get what any student that I pick will be a girl. So it means I'm easily able to predict. So once I'm able to predict that every student that I will pick from Wesley Girls from Holy Child will be a girl, then it means that experiment, that activity can never be regarded as a random experiment. Is that clear? So you shouldn't be able to predict. Once I'm able to predict that there is no way I will get a boy, okay, my selection will be a boy in Holy Child in Wesley Girls, okay, should mean that I am dealing with what? A random what? Experiment. If I'm able to predict, then it ceases to be a random experiment. That's all. However, in that same class, okay, the students have names. So if I'm selecting particular students, okay, and I just pick them without any favor, okay, then it means I'm looking at my event, okay, or my experiment to be equally a random what? Experiment. So random experiment deals with what? An experiment that is fair, and therefore it will give you a fair result with no issues. So no, nothing attached. You shouldn't be able to predict that when I come to class, okay, this particular class, and I'm going to call a girl, this is the girl that I will always call. No, you shouldn't be able to predict. Once you are able to predict, then it means that randomness has been taken out. Is my point well made?
Yes, please.
Very good. All right. Okay. So we have an example here. When you throw a die, I've given you other examples outside what we have here, which you could relate. So when you throw a die randomly, once it is a fair die, once it's a fair die, if you throw it, you cannot exactly predict. That's where when you are playing Ludo, and you want 6, you pray that you get a 6. Okay, immediately you flip the die or you toss the die. Okay, you should know that if you are looking for 6, it doesn't mean that automatically 6 will come. okay, it will just come by chance. So if you're able to predict, okay, that you are going to get sales, then it's not fair. What we usually call in our local parlance as dalega, you know that. So if you do dalega, okay, which is unfair, where you roll the die in a way, okay, that you are able to predict the result, then it means what you are doing is not fair, and therefore that experiment, that trial, is not a random what experiment or trial. Is my point well made now? Because you are able to predict, you are certain of the result, okay, that will come, or you are certain of what the outcome. Is my point well made?
Yes, please.
Very good. Okay, so now let's move on to the third one, which I'm taking time, okay, explaining this because I said I will be using it often. And sometimes when you read questions and you take note of some of these terms, okay, you always bring the question home. So the question will become very easy for you. So please pardon me if I take time, okay, explaining the concept here because I know it holds the key to a certain future. Okay, so now let's see. We are looking at an outcome. Okay, probability is so much connected with sets, SCTS. Okay, so when you are dealing with sets, okay, and I give you maybe this particular set. Let's look at the sets. If I give you the set here, okay, let me see. Let me pick. Okay, so if I give you the set, let me pick my, excuse me. Okay, I'm coming. Okay, so assuming I give you the set, a set, okay, A, okay, to be equal to maybe 1, 2, 3. How do you call the 1, 2, 3 that you have there? Okay, how do you call what the set contains? What is the name given to what the set contains?
Element.
Element. So when you are dealing with sets, okay, what you have in the sets, okay, will be called elements. However, when you are dealing with probability, okay, we give these elements special names, okay, and the name will be what? Outcome. So where we have elements for sets, okay, outcome will be for probability. So indirectly, the two can be used interchangeably. However, you should know, okay, when to use the exact, okay, one, or when to be more what precise. So it's the same thing. Okay, so that's what we have here. So an outcome is a possible result, okay, you can get from doing a trial or an experiment. So if you do a trial, and if I'm talking of sets, okay, and maybe I'm talking about the elements, maybe 1, 2, if I roll a die, 3, 4, 5, or 6. Okay, in terms of if I don't tell you that I'm dealing with rolling a die or maybe probability, then what you have here, the numbers here, okay, will be regarded as what element. But once I'm dealing with probability, the elements here will be regarded as outcomes. I hope I'm clear enough.
Yes.
Very good. Okay, so for example, okay, you could get a head or heads when tossing a coin, or get a 2 when rolling a die. So the head, okay, is what we call the outcome. The 2 is what you call what the outcome of that what experiment. Okay, and we can also call, okay, outcomes as what sample points. Okay, so another name for outcome will be what? Okay, sample point, as simple as that. Any question before we move on to our next, okay, term, and therefore our next slide? Are we all fine? Okay, all right, great. So if you are fine, then let's move on to the next one. Okay, so the next one is an event. Okay, an event. Okay, all right. So, okay, I will try and connect all that I'm saying, okay, henceforth with set, which you are so familiar, okay, with. Okay, so event, okay, an event is an outcome or defined collection of outcomes of an experiment. Okay, that is, an event is any subset of a sample space. Okay, so in sets, okay, if I have maybe my universal set, which usually you can see that I've made mention of sample space here. I will define sample space very soon. Okay, so if I have this, you should know exactly what I'm talking about. Assuming in sets, if I have my universal set mu to be 1, maybe 2, 3, and maybe I have a set A, okay, maybe 2. Okay, you can say that A is a subset of U, is that not it? Or mu. Okay, however, in probability, this subset that you have here is given a special name, and that special name is just what? The event. So event basically will be the same as subset in terms of sets. However, this time around, it will be subset of a particular universal set. And universal set in terms of probability is what we call the sample space. That's all. So indirectly, I've defined, okay, or okay, explain the term sample space that you have here. So in sets, okay, your sample space, your overall, okay, set, your bigger set will be the universal set. However, in probability, your bigger set will be what? Hello, in probability, what will be your bigger set?
The sample space.
The sample space, as simple as that. Okay, so here we have experiments and their corresponding sample spaces. Okay, so let's look at, if you toss a coin, you know that it's either you get a head or a tail. Okay, and who can, I want someone to tell me, how do you determine that this part of the coin is the head and this part is what? The tail. How do you make that determination? How do you distinguish between the head and tail of a coin? Okay, anyone here? Okay, my professors, let's go. I'm waiting. Or I'll start calling you by. How do you determine that this part of the coin is a head? Is it by instinct or there is a particular rule? Oh, does that mean nobody knows? Okay, so let me check if all of you are with me. Okay, Eddie, are you there?
Yes, sir.
Okay, all right, great. Irene, are you there?
Yes.
Okay, Ellen.
Yes, please, I'm here.
Okay, Rabna.
Yes, please, I'm here.
Okay, Lorraine. Lorraine, if you don't respond, you'll be a suspect. Ishra. Okay, Ohinewa. Okay, Paula, Regina. Okay, so those of you who didn't respond, okay, you are a suspect. I'll start throwing you questions, okay, to you. Okay, now, this is it. Okay, so if you want to, if you have any coin, okay, at first, you see that one face of the coin, you see a head. Okay, I mean the head of a prominent figure. Okay, there. So that you can easily determine that this is the head because on that face you see a head, and the other face will automatically become what? The tail. So once you're able to get the face that is the head, automatically the other one, the tail, is determined. Okay, now it's not always that you see a head, on the face of a coin. However, if you don't see a head, you see a particular, let me call it, a symbol of authority. Okay, maybe the coat of arm. So if you take a coin and on the face you see a coat of arm there, okay, or you see the coat of arms, then you should know that that face is what you are supposed to take as the head of the coin. and the other face automatically becomes what? The tail. Is my point well made? Hello,
Yes,
am I clear
please.
on this? Very good. So
Yes,
that's how
please.
you can easily.
Zahman,
Yes, please.
can you please repeat what you said?
Okay, so I said that, okay, at first you could easily determine, okay, the head of a coin and the tail, because at first all the coins that you get, you see a head on a particular face, okay, of the coin. So automatically that side of the coin becomes what? The head. But now you will not always see the head, okay, more or less embossed, okay, on the coin. But if you don't see the head, you see a symbol of what? Authority. Okay, maybe the coat of arm. So when you take a coin, you just check. I think the 20 pesewa or a pesewas coin, okay, you see, let me see whether I can get one or if I remember. Okay, yes, on one face you see the coat of arms, if I'm right. And the other face, I think is cocoa or so. Okay, but the face that you have the coat of arm, you can see the coat of arm is a symbol of authority. You agree with me?
Yes, please.
So that face will be regarded as what? The head of the coin. And the
Okay.
other side automatically becomes what? The tail. Is it clear now?
Yes, please. Thank
So
you.
it's either you see a head or a symbol of authority. All right. Okay. So this is it. Okay. Well done. Okay. So let's go. And if you roll a die, you know that this will be the set of possible outcomes. And if you put the outcomes together, and that will make what? The sample space. When you toss two coins, okay, you are going to get this. And I believe some of you are asking, how did we get this? Right? How did you get this, or how do we get this as the outcomes, okay, that will make what? The sample space. Very soon you will know. However, I will give you a gist here. Okay, anytime I'm going to explain this way, okay, I'm going to build a table. You can always use a table to get, okay, your set of possible outcomes. So assuming I have this, the first part of the table, okay, the row part, I'm going to get maybe a head. So I'm going to use head, okay, then a tail. Then this second side will also be a head, okay, and a tail. Because for every, okay, coin that I toss, the first one, so let's maybe look at the first coin, then maybe the second coin. Okay, so the first coin, this will be the possible outcome, head or tail. The second coin, this will be the possible outcome, head or tail. Okay, so if you want to look at the possible combination of the outcomes, then you can see that it will be H, H. So this will give you H, H. I hope you are following.
Okay.
And you can also have what? H, okay, T. You can equally have what? TH. Okay, and now this will give you TT. So that's how come we have this. Is that clear?
Yes, please.
Okay, so you can do same for that of the 3 coins to get what we have here. Okay, so for 3 coins, this is what you do. Okay, usually, okay, if you have even, you can see that 2 is even. If it's even, then it means you divide it into 2 equal halves, which will be 1, 1. So that's why you have, okay, 1, okay, that is 1 coin with a set of possible outcomes being head or tail, and the other coin, 1 coin, head or tail. But if you have 3, you can see that 3 is not even, it's odd. What you do is you cannot break it into 2 equal, in terms of dice. Okay, I cannot have 1.5, okay, coins, okay, or maybe 1.5 die. Okay, so please take note. So once you cannot divide into exactly, okay, 2 equal halves in terms of what we are looking at, then what you do is, okay, break it into 2, maybe 1, okay, and 2. So if you combine, you get 3. So in that case, if you are building your table, this is how you will build your table. Okay, one side, which is the row here, maybe will be head, head, and that will cater for the set of possible outcomes in one, coin. Okay, and the other one too, where you have the two. Okay, you are going to use, what you have here, because if I have 2 coins, and I toss, this will be the possible, set of outcomes. So it means you write the head, head here, the head, tail here, the tail, head here, and what's the tail, tail. I hope you are following. Hello, are you following?
Yes, please.
Okay, so if that's the case, on your own, give me whatever that you are going to get here. So I'm going to complete the first one. We do the first one together, and that will give you head, head, head. So you get head, head, head. So continue for me, then we come and complete the side. So head, head, head. Is that clear? So continue. The next one will give us what?
Head, head, tail.
Okay, so head, head, tail. Okay, I will ask you one after the other and see if you are all attentive. So head, head, tail. Okay, so let me see. All right. Okay, so who will be on my radar? Okay, Inshira. Okay, what will be the next outcome?
Head, head,
Mhm.
tail.
Head what?
Head, tail.
Head what? I didn't hear you well.
Head, tail.
Okay, head. Okay, so we want to move in this direction. You can see that if you pick this, what do you have there? It is head, tail, before you come and combine it with this. So let's go.
Head, head.
Head or tail, head. Perfect. So that will give you head, tail, head. Okay, in the order, in which you place these outcomes, not necessary. What is important is the outcomes should be there. Okay, that's all. So now let's look at, the next one. Okay, Paula. Paula, what will be here?
Tail, tail,
Head, tail, tail. Okay, very good. So head, tail, tail. So I believe with that you can continue the rest for me. Is that clear?
Yes, please.
Okay, so very soon I will walk you through another way of making this determination in terms of the outcomes that will make what your sample space. Okay, but for now we'll make do with this, and this is very critical. Sometimes I always advise my students, if you know this off head is good, if you know this off head is also good. Okay, the set of possible outcomes. Okay, when you toss what 2 coins, or you toss 3 coins, and it will always be the same as when you toss a coin 2 times. So when you toss 2 coins once, the set of possible outcomes will be the same as when you toss 2 coins. Let me come again. When you toss 2 coins once, the set of possible outcomes will be the same as when you toss 1 coin twice. Is that clear?
Yes,
Hello.
please.
Okay, it's the same thing. So if you toss 1 coin, what do you call it, 3 times, that will be the same as what?
3 points.
Okay, 3 coins tossed once is the same. So please take notes. Okay, don't be. So along the line, you get to know this better. Okay, so now let's continue with our terminologies, our terms. Okay, so quickly, let's look at our next term on the line. And that is, we are dealing with some types of events. Okay, types of, you mentioned events and we know what events are. Okay, who can tell me briefly what an event is? I want someone to tell me simply, in
It's
simple.
an outcome.
It's an outcome. Okay. I won't take it entirely. Embellish it a little. Okay, Lorraine.
An event is any subset of a sample space.
Period. That is it. As simple as that. Okay, it will always contain an outcome anyway. Okay, it can even be an empty set, because you know that every empty set is a subset of the universal set. Is that not it? Okay, so it shouldn't necessarily be an outcome. That's not to say that your outcome could be zero. I mean, it could be nothing. Okay, there is no outcome at all. Okay, so very good. So simple events. Okay, when we mention simple events, you should know, and I'll be using that very often. And sometimes the question alone should, if you are able to determine that this probability question is dealing with a simple event, it will guide you as to, okay, your approach in dealing with it. So an event with a single outcome. Okay, for example, okay, getting hairs, okay, with a single toss of a coin, or rolling a 4 on a die, okay, is simply a simple event. Should I come again? Should I throw, or it's clear? Is it clear, or I should come again?
Clear.
It's clear. Okay, so let's move on to, so if you know the definition of what simple, you should know that of what the compound. Okay, so an event with more than one outcome, okay, is what we call a compound, okay, event. So simple with exactly one outcome, compound with what? More than one outcome, as simple as that. Okay, so okay, so a compound event consists of multiple events which occur simultaneously or in succession. So we are dealing with, okay, more than one what event. So rolling 2 dice, okay, is a compound event. Okay, because you can see that you are dealing with 2. Okay, so if you have only 1 die, okay, immediately perform your experiment. That experiment, okay, what will come out of it will always be a simple result, and therefore a simple event. Is my point well made? Okay, so anytime you are dealing with more than one particular, okay, I should say, tool in getting your outcome. Okay, if you have 1 tool, let's say a die, what will come out of it will be a simple. But if you have 2 dice, if you have a die and a coin, okay, you are dealing with what? Compound event. So you can have 2 coins. If you are dealing with 2 coins too, okay, you are dealing with compound event. However, if you are dealing with only 1 coin, the outcomes will be simple, okay, events if you put them together. Is my point well made? Okay, and sure or certain events. Indirectly, I've explained that. So when you are sure that, okay, your results, okay, the event will always occur, then you know that, okay, this particular event that I'm talking about is what? Is a certain or sure event. So it's like the event of going to a class and meeting all girls in Wesley Girls. So if immediately I enter the class, okay, I will see that what I have there, simply if I perform that experiment, what will come out of that will be a girl. Okay, and the other one will be uncertain. That is you, okay, meeting a boy, and that will be the unsure or uncertain event, which we sometimes call impossible events. So quickly, let's look at that one too. So impossible or null events. Okay, so once you know the definition for certain or sure, you should know that of what? The null or impossible. It's just the opposite. So I'll briefly talk about it. An impossible event is an event that will, okay, not and cannot happen. As simple as that. So if I roll a die, okay, is it possible for me to get, okay, a 7? Okay, so it means, okay, that event cannot what occur, and once that event cannot occur, then we are dealing with an impossible event. If I roll a die, okay, and I ask you the set of possible numbers that you can get will be 1 up to 6. So any event that will involve 1 up to 6 will be a possible event. Otherwise, outside that will give you the impossible or null event. And again, equally likely events. Okay, when we say that two events are equally likely, it simply means that they have the same probability of occurring. So if you have, let's say, a coin, okay, so if I have a coin and I toss the coin, I know I'm going to get what? Okay, we'll either get a head or a tail. Is that not it? Hello? Are you with
Yes,
me?
please.
So you get a head or a tail. So your sample space will be this. Okay, now if you are looking at probability of getting a head, you know that will be the number of heads here, which will be 1 over 2. That is probability of getting a head. Is that clear?
Yes, please.
Okay, what will be the probability of getting a tail? The number of tails here, and you see 1 over the number of elements in your sample space, and that will be what? That will be 2. So you can see the probability of getting a head and getting a tail, okay, will be what? 1 over 2 each, and will be the same. So in this situation, we'll say that the events are equally likely to occur. Is that clear?
Yes, sir.
Okay, so now let's see. If you roll a die, will each event, I'm talking about getting a 1, getting a 2, getting a 3, up to getting a 6, will the events be equally likely?
Yes.
Okay, and what will be their corresponding probabilities?
About 1/6.
1 over 6. So it's the same thing. Okay, so in this case, okay, so those of you who didn't get it, okay, if you are looking at rolling a die, your sample space will be made up of the following outcomes: 1, 2, 3, 4, 5, 4, 6. Okay, so if you are looking at probability of getting a 1, okay, this will be equal to how many ones? Your event will be 1. So the number of ones here, you get 1 over the number of elements in your sample space, which is the number of S, and that will be 6. Okay, if you do probability of 2, it will also give you how many 2 outcome do you see with the number 2? It's only 1, so it will be 1 over 6. If you continue, you see that all of them will have 1 over 6. And since each event, okay, you can see that they have the same probability. Okay, that is the likelihood of what occurring. We are looking at what your event to be what equally likely. Is that clear? So if I mention equally likely events, now I believe that you should be able to what relate and relate very well. Am I clear?
Yes, please.
Very good. Any questions at this point? Okay. All right. We have some special events which I have shelved. We'll look at it later because they are special. So we have what we call mutually exclusive and non-mutually exclusive events. Okay, we have what we call complementary events. We have what we also call, I think, yes, dependent and independent events. These 3 events, okay, I'm considering them as 3 events because, okay, they move together. Dependent and independent move together. Mutually exclusive and non-mutually exclusive move together. So in effect, we have 2. Then we have complement events. So these are special events which we'll look at what later. Okay, so now this will be the events that we will consider. Okay, so if you don't have any question, let's go and look at, okay, the 3 diagrams. Okay, so quickly, let's look at what we have there. Okay, anyway, let me ask, if I may ask, okay, is this new to you? Is this the first time you are hearing a 3 diagram or 3 diagrams? Is it the first time?
Yes, please.
Did you say yes?
Yes.
Okay, all right, then it means, all right, okay, my work, I need to talk a little more. Okay, so this is it. Okay, just as you can see, we are looking at what? 3 diagrams. So in the name, you see tree, but we are not going to draw a tree. Okay, it's just that the nature of the diagram resembles that of what? Of a tree. So quickly, let me take you through this, then I will throw a little more light on it. So this is a device consisting of line segments, okay, which will be the branches, emanating from a starting point, which I am calling the root. It might not necessarily be what? The root. Okay, it can be starting from, okay, it can start from maybe somewhere here, okay, which obviously is not the root. Okay, it's okay connected to what? To the main what? Stem. So now this is what we have. Let's come to, okay, the continuation. Okay, and it can also, so, and also from the outcome point. So it's not always that, okay, or only that your branches, which is the line segment, will move from the root, the source. Okay, it can also move from what? Your outcome points. Okay, your outcome point, and what we also call, yes, call the sample point. Okay, outcome point is the same as the sample point. Okay, so please take note. It is used to, okay, so this will be the use. Determine the sets of all possible outcomes of an experiment, and it comes with a condition. Okay, provided the alternatives are not too numerous. If the alternatives are too numerous, though you can do it, but it will waste your time. You can use it to determine the set of possible outcomes, but you can waste your time. Then you can also use it to determine or calculate probabilities. However, we are going to concentrate on the first one. We will only use the tree diagram to determine the set of possible outcomes. Okay, on further studies, which is outside, okay, your scheme of work in SHS, okay, you will be taught how to determine probabilities using the tree diagram. Okay, so the advantage of the tree diagram is that they can be used when more than one event is involved. So it means if I'm dealing with an experiment that involves more than one event, okay, then what type of event am I looking at here? If you are indeed following. If your event involves more than, okay, your experiment involves more than one event.
Compound event.
Compound event, perfect. Okay, so it means you will usually use, okay, it's convenient to use the tree diagram when you are dealing with compound events. Even for simple events, you can easily get their probabilities, their outcomes easily. Okay, and therefore the probability. So any questions? Okay, have I made my point clear or myself clear?
Yes, sir.
Great. All right. Okay, so now, okay, let's see how best we can use, okay, this concept that we have here. So this is it. This is how, let me go back a little. Okay, so your tree diagram, this is how it will not look like exactly like this. But once you start from the roots, okay, oops, forgive me. All right, so let me pick my pen. So you start from the roots. So this is what you have. So maybe this is the root. You have what do you call it? An outcome, two outcomes. So you say if I roll a die, I'm going to get what this outcome. So the first trial will be 1, 2, 3, 4, 5, 6. So it means the number of outcomes that you get in each trial will determine the number of branches that you are going to get. Am I clear? Okay, however, I have looked at only one simple event giving me these branches. So 1, 2, 3, 4, okay, 5, then was 6. Okay, that's my first trial. So if I roll the die again, so I'm looking at when I have 2 dice rolled twice, or okay, 2 dice roll once or 1 die roll twice. This will be the situation that I will be looking at. However, I won't do this. Okay, I'm going to look at the head and tail because that will be very easy. So let's deal with the coin situation. So I have my first trial will give me head, tail, forgive me. Okay, this will be my first trial. My second trial, if my first gave me a head, okay, and I'm going for my second trial, equally the second trial will have two outcomes, head or a tail. The next one, if my first trial gave me a head and I'm going for my second trial, it will equally give me a head or a tail. Is my point well made? Or I should come again?
Please come again.
Okay, so I said, remember I told you that the tree diagram is used under certain situation or is convenient, okay, under certain situation in terms of its use. And look at it, you said provided the alternatives are not too numerous, and the alternatives will basically be the outcome, the possible outcomes in the trial. If you look at a coin, okay, how many outcomes, we are possible outcomes, we get 6. So that will tell you that you are going to get 6 branches, okay, to deal with. So if let's say I give you 1 up to 10, and I mean one event, 1 up to 10, another event, okay, maybe 3 up to 12, and I ask you to find a compound event and give me the possible outcomes. Because the alternatives in terms of the possible outcome in each simple event, okay, will be numerous, it is not convenient to use what? The tree diagram. Okay, though you can use it, but it will not be convenient. Okay, all right. So now it means dealing with coins, it is better, okay, to use the tree diagram, or easier to use the tree diagram to get your set of outcomes that will make your sample space. So if I have a coin, I know that anytime I go for my first trial, the set of possible outcomes will be what? Head or tail, is that not it? So I basically have 2 outcomes. So meaning I'm going to have 2 branches. So if my first trial will always start from the roots. Okay, so from the roots, I'm going to get 2 branches. 2 branches in the sense that my first trial will give me 2 possibilities, either a head or a tail, or 2 possible outcomes. Then if my first trial gave me a head, you are not supposed to end it because the coin must be tossed twice. So you perform the experiment twice. So your second trial, this is what we have. You will do more, and that's where we'll end anyway. Your second trial will give you, okay, if your first trial gave you head, and you are going to throw the coin again or toss the coin again, you still have 2 possibilities, either a head or a tail. So it means now the outcome point here is also going to have 2 branches. Is my point well made? So that's why we said line segments, okay, emanating from a starting point, and it can also, okay, move from what? An outcome point. So you can see that these 2 will be from the roots, which is the starting point, okay, and here is starting from these 2 branches are starting from the outcome point. So you do same for the tail. If your first trial, the result was a tail, the outcome was a tail, okay, if you are throwing again your second trial, it will either be a head or a tail. So if you want to get, okay, the possible outcome, the set of possible outcomes, you read along the branches. So if you read here, you can see that the first outcome here, okay, will give you head. The second one will be head tail. I hope you are following. The third one will be tail head. And the next one will be tail, which is exactly the same as the one that we use the table to generate. Is that clear?
Yes, please.
Okay, very good. So now to the main work. Okay, all right. So this is what we have, okay, as our practice example. So draw a tree diagram to show all possible outcomes in the following experiment. Indirectly, we've done the first one. So the first one, flipping a coin twice. Flipping a coin twice. Okay, then 2, flipping a fair coin, okay, twice or 3 times. Then flipping 2 fair coins once. Okay, then 4, flipping 3 fair coins once. Then the 5 will be yours. Okay, tossing a fair coin, okay, 4 times. So the 5 will be your assignment, and I will instruct you as to what we do, okay, with that assignment for me to get it, especially those of you joining us for the first time. So now let's go and look at the solution. Okay, so the solution, this is what we have. Indirectly, the one we've done it. Okay, we are looking at tossing, okay, a fair coin twice. So your first trial, Okay, so your first trial, let me go. So the first trial, this is what we have. Okay, it will start from a point. Okay, so let me put it this way. Okay, so this is what we have. Okay, we have our point. Oops. Okay, it will go. So it will start from a point. You have two branches because you know that your first trial will give you a head or a tail. Okay, so this will be your first trial. Okay, and I'll write just first there. Okay, and second. If you get a head, the second one will also give you a head or a tail. Okay, and equally a head or a tail. I've explained that. So I'm not going to spend time on that. So your sample space, your S, will be, we said it will be HH. You read along the branches. Okay, then it will be HT. Okay, then you get what? TH. Okay, and you get what? TT. So this is what you have for question 1. Now let's go and look at question 2. Question 2, what do we have? A fair coin 3 times. So let's see. Okay, that is where we will end. Okay, so 3 times. So 3 times, it means we will perform the experiment how many times? How many trials?
3 times.
3. Okay, so you know where to start. Okay, so we are going to start here. So you have your first. Okay, let me pick my. Okay, so you have this. Okay, your first one. Okay, you also have 2 outcomes from the first one. So you have a head and what? And a tail. Okay, this will be your first trial. Okay, if you are going for your first trial has occurred, and you have to go for your second trial. So when your first trial gave you a head and you are going for the second trial, you know that the second trial equally will give you head and tail. So you have head here, you have tail here. Is my point well made?
Yes.
Okay, so this will be the second trial. Okay, and again, you get what? If you come to this one, if the first trial gave you a tail, a result, outcome, tail, and you are going for your second trial, you still have 2 outcomes. So you should have 2 branches, okay, emanating from this time around the outcome, okay, point. Okay, however, we can't end here because we are dealing with 3. So it means we have to go for our third trial. So if your second trial gave you head and you are going for your third trial, what will be your set of possible outcomes? How many? Your third trial, how many sets of possible outcomes will you get there? How many outcomes? Hello? Are you there?
Please 8.
How many outcomes?
Um,
Okay,
6.
you remember, you are dealing with a coin. So anytime you flip, okay, that is your trial. So if you are going for your next trial, okay, if I have a coin and you flip, what will
With 2
be
outcomes.
2 outcomes? You still have the head or tail. So if my second one gave me second trial, my result was a head, and I'm going for the third trial, I can still get a head or a tail. Do you agree now? So it means for each of the outcome points here too, you are going to have 2 branches. Okay, head, tail. Okay, head, okay, tail. So now we are going to read along the branches. So with this one, your sample space, your S, will be, let's go. If you read the first reading, what do we get? H, H, H. Are you there? So that will be the first outcome, possible outcome. Let's look at the second reading, H, H, T. I hope you are following. Hello? My professors, are you there? Are you following? Okay, so help me complete the set of possible outcomes. Let me see if I can call some of you. Ohinewa, let's go, if indeed you are following. If you read along the next branch, Ohinewa, let's go. Ohinewa, you are a suspect. Okay, Eddie, let's go.
Head, tail, head.
Head, tail, head. Perfect. Head, tail, head. Okay. Regina, let's go.
Head, tail. Head, tail, tail.
Very good. Head, tail, tail. Okay. All right. Inshira.
Tail, head, head.
Okay, so tail, head, head. Irene. Irene, are you there? Okay, unfortunately, I can't hear you. Irene, are you there? Okay, Laureen, let's go.
Can I see?
Okay, Irene.
Tail, head,
Tail. Okay, head, tail. Perfect. Okay, comma. Laureen.
Tail, tail, head.
Tail, tail, head. Okay, then let me see. Okay, who has not been on my radar? Okay, let me see. Okay, Irabna.
Tail, tail, tail.
Tail. Okay, we did what? Tail, head, tail. Okay, no, you done tail, tail, head. Okay, then now tail, tail, tail. So you can see that it's the same as, have you exhausted?
Yes.
Okay, all right. And you can, are you sure? Let's see whether you've exhausted. Okay, 1, 2. Okay, so 1, 2 for each of them. So 8. All right. So you can see that obviously, okay, what we have here is the same as you using the table. Remember, we use the table to generate, okay, the sample space for this situation as well. Okay, so that will be it. Okay, for today. However, this will be your assignment. Please take notes. Well done, you've done well. Okay, I've told you that flipping. So if you want to use the tree diagram to get the solution for flipping 2 fair coin ones, the result will be the same as this. You agree?
Yes.
Okay, so it means indirectly we've done this one as well. Okay, then flipping 3 fair coin ones. Okay, okay, as for that one, we should have done it, but I'm going to leave it. But this one, if you're able to do this, then you should be able to do the question 4. So please take notes. We are going to end here. Well done. Okay, it wasn't easy from the beginning, network issues, but okay, at least you stayed put, you were resilient, and you've been able to do something.